times -1, -5.
So what did you ask?
What is the momentum of the 5 kilogram after the collision? Just mass times velocity. The total is -1, but this one specifically is -5.
Oh, okay.
Therefore, if my total is gonna be -1 and this one is -5, what is this?
Is that gonna be just 8?
Is it 4? D?
And what's that for?
Alright, so let's work through what we're thinking here. My momentum and the total momentum initial equals the total final. Initially, I have 15 plus -16. That's my total initially. Afterwards, I got I have -5 plus x for the lack of movement. It's my unknown.
Oh, this is a part of the same problem. I
Yes.
was wondering what-
Oh, okay, yes.
Sorry, I'm so confused. Now I understand.
My total before is -1, my total after has to be -1, and that's -5 plus whatever is my unknown here. So the momentum of the 8 final has to be 4 Descartes or kilogram meters per second. And so now, if I ask what is the velocity of this afterwards, well, that's equal to mass times velocity. That's equal to 8 kilograms times V8 final. So V8 final. People here are decimal fans, so it's 0.5 meters per second.
When you putting this recording out? When you putting this recording out?
I don't know, did I?
No.
I'm just making sure I actually started the recording.
No way, mister.
Yep, nope, it's recording.
Okay, sir, you gonna post it maybe tomorrow?
Most likely. I'll at least have it on YouTube by tomorrow.
Okay.
All right, so here's the power that we were able to show right here. If we just stuck with Newton's laws, we would have to worry about, all right, so this object's coming in, there's no acceleration to start with, they collide, suddenly I have forces involved, there's acceleration. They both slow down, stop, and then they bounce in opposite directions. We would have to know how that force changes, because that force is not constant when they hit. It starts out at 0, it goes to some maximum amount, and then they separate and goes back to 0 again. We would have to know how the force changes over time while they're touching each other in order to calculate this using Newton's laws. Or, with momentum, I don't care what happens while they're touching each other. All I know what happens beforehand, I can predict what's going to happen afterwards. And that's the power of this. And I think this momentum thing that we have right here, I think about 5 minutes to let it sort of sink in, just so you just get excited about coming back, and we're going to do another one of these, because I'm not convinced that everyone is comfortable yet. Some of you are, some of you aren't, you know, it's like most classes. All right. Very similar to the problem we just did, but I've made one change. The 8 kilogram object is moving to the right initially. So let's do them separately to start with. What is the initial momentum of the 5 kilogram mass?
15 Ds.
Should be the same thing as we had before, nothing had changed on that one.
Besides, that one isn't gonna be negative.
Okay, what will it be?
It's like 16, it's 16 kilograms per meter. D. I wanted to say it all.
Yeah. All right.
16 kilograms meters per second.
All right. I think you had a third way of writing that units there. All right, so what is my total initial?
1. 31.
Yeah, because you just add them straight up.
I know.
It's now changing.
Right.
All right, afterwards, what's my total momentum gonna be afterwards?
Still 31.
Yes, still 31, because that's the whole idea of conservation momentum. It's not gonna change. The total will stay the same. So P final. Now let's look at the parts. What is the momentum of this one after the collision? Say it again. My total is 31, so I got -5 plus something gets me 31.
24? No, almost. 26. Get you 31.
What did you say? I wasn't sure if you said 26 or 36.
I said 26. That'll get you 31? Or no?
Ooh. 26 plus -5 is 21.
Oh. -5, okay.
It's 36.
Yes, 36. 36 plus -5 is 31.
Okay, okay.
Finish it off.
D.
Okay. So now, how fast is the 8 kilogram mass going after the collision? Well, that's gotta be equal to the mass times the velocity. That's equal to the 8 kilograms times whatever its final velocity is. Which is 4.5.
How do we get 4.5?
From this right here, the math problem is 36 is equal to 8V. That's the math problem.
Okay.
Divide by 8.
Yes, smart.
So 36 divided by 8. I know 8 times 4 is 32. That give me a remainder of 4.
Okay.
So just changing that one sign from that -2 to a +2 suddenly changed the velocity of this from 0.5 meter per second to the right to 4.5 meters per second. It's going 9 times faster just by switching that one sign. Right? Questions to hear? Oh, all right. So now we have these numbers here. The 5 kilograms starts at 15D and goes to -5D. So let's look at what is the change in momentum of the 5 kilogram mass.
What's the triangle again for?
What's the what?
Is it 20?
The triangle, 620.
Oh, the triangle means change. So what's the change?
There's 20D in it.
Close.
Oh, is it negative? No.
You gonna let him flounder over here, or does somebody wanna help him out? Or you just good for floundering?
I'll get it eventually.
Is it 26.5
Mm.
D?
No, I wasn't picking on that one. If it's a unit thing, I would've gone something like that. Different gesture completely.
So it's not 26D?
It is not 26 feet. Unless I've done something silly here. Nope, I haven't.
Is it,
Is it negative 20 D?
Now, before you dismiss that,
Yeah, I know.
what's changed?
I don't know, it's been stuck in my head, watching you do this, it's just been
How do you find change?
subtracting?
the final minus the initial.
Yes, final minus initial. My final is -5. My initial is 15. I'm just looking at the 5 kilogram mass, not looking at the whole thing or any other parts like that. It's -5 minus 15, which is -20 D. The change in, sorry,
What was the question to make you guys say that you have to, subtract the final, the initial time, in the final?
so whenever you're finding change, it's always final minus initial.
Okay,
So this is final minus initial.
okay.
I think there's potentially 3 always that show up in physics. Forces always come in pairs. Change is always final minus initial. What's the third one? Oh, the forces in that force pair always act on different objects in opposite directions. So the change in momentum of the 8 kilogram mass. Somebody might have just said it and I missed it. Heard
Is it-
I
someplace.
heard 8.
Ah, not 8.
Negative 11.5?
No? Wow, people are going way more complicated than you need to on this one.
Is it 20 D?
Yes.
What's wrong with him?
What is the final momentum of the 8 kilogram mass?
Okay, 36.
Oh, I thought it
What is
was
the initial momentum of the 8 kilogram mass?
16.
Just 36 minus 16.
Where was I looking at when you see?
I think part of the problem, yeah, I think there's a lot of numbers up here and trying to figure out which is the number to look at.
No, cause I was trying to subtract 8 from 16, instead of looking at the final, which was 36.
Yep.
Got you.
Now, another thing with conservation of momentum is this lost 20 units of momentum, and this gained 20 units. It basically transferred 20 units of momentum from one to the other. That's how momentum stays conserved, is the total stays the same just because whatever one loses, the other one gains.
Okay, so the reason why I did that is because you had the 5 and the 15 right there for the first one.
Oh.
And you guys got the 20 out of that. So that's why I did 8 and 16.
Oh, yeah, that 5 comes from this over here, not from the mass of the object.
Mm.
That, yeah, so the first time I was comparing those right there.
Okay.
Yeah, I try not to have problems with the numbers repeat, but obviously failed this time. It was just a mess with the other toy.
I think, okay, so you, subtracted the 16 from 36.
Yes.
And that's what got you the 20.
Yes.
Okay.
Questions? I'm about to flash back to something that I've erased, which unfortunately I erased, but I'm gonna write it up again. When we went through the derivation, I'm gonna do the left-hand side for a bit, faster than we did before, because you already have it in your notes. Any questions before I erase some of this stuff? And I'm about to get to my most obscure reference of the course. Even more so than Bobby Sherman. Or G2 Kombucha. I think all of you are too young. All right, so we started out with force on A from B times time. This is where we started. I'm just gonna do the left-hand side of what we had before. So this was mass of A times the acceleration of A times time, which was the mass of A times the change in velocity of A, which is mass A, velocity A final, skipping a couple steps there, mass A, velocity A initial. So this is P final minus P initial. So we got that far in when we were doing the derivation, and then I started flipping sides. This right here, though, I'm going to do something slightly different. This is just the final momentum minus the initial momentum, which is the change in momentum. So I have this force times time is equal to the change in momentum. Force times time, also change in momentum, has a special name. And here's the obscure clue. When someone suddenly buys you flowers, that's called
A nice person?
people usually come up with words like that. No, it has nothing to do with being nice.
Oh, thoughtful.
It was a perfume commercial in the 70s.
70s?
All of you were too young. Probably.
Yeah.
All right. Was that?
None.
In the commentary for chapter 6, I actually have a link to it, the YouTube. It's on YouTube. It's called Impulse.
It says NA for, and then
M sub A,
A, one.
acceleration sub A times time.
Nope, no, third one. Third, yeah. What is it, a and an F?
Yes, for the velocity of A final,
A final.
minus the mass on A times the velocity of A initial.
Okay.
We're really leaning back on that one, on these.
Okay.
So when you are in terms of seatbelts, if you're not wearing a seatbelt, what's going to stop you is the dashboard or the window, steering wheel, something hard right in front of you.
The airbag.
You modern people. Let's assume that it's a vehicle I own and there's no airbag.
Is that illegal?
Yeah, that's old enough.
Okay.
I didn't know airbags were required at this point.
I don't know, I'm not from the state.
As long as you have two mirrors and some headlights, you're fine.
No.
So you're driving around in your grandparents' 1930 something. Your grandparents' 1960 something. So when you hit the dashboard or windshield or whatever hard surface that is, the time it takes to stop is very short. Your change of momentum is going to be the same. You're cruising along at 60 miles per hour. My mass is 100 kilograms, so whatever yours is compared to that. So if I stopped, I could have 100 kilograms going from, 60 miles per hour is about just under 30 meters per second. So we'll just round it off, 30 meters per second, 100 kilograms. So 3,000 Descartes, yeah, still up there. 3,000 Descartes of momentum going down to 0. That's gonna be my change in momentum. If the time is short, because I hit something hard, that force is gonna be huge. The airbag, though, increases the amount of time it takes to stop, thereby reducing the amount of force required. These are inversely proportional for the same change in momentum. Now, oftentimes, the question is, what is the change in momentum, or what is the impulse? Which formula do you use? You use the one for which you have information. If I apply a 5 Newton force for 5 seconds, I'm using this formula. If I have a 5 kilogram object that goes from 30 meters per second to 20 meters per second, I'm going to be using this formula. They're equal to each other. This also brings up something about units. So before I talk about units, any questions? Because this and this are equal to each other, the units have to be equal also. So the units of force times time must be equal to the units of momentum. So that would be the unit of force times the unit of time. It's equal to the unit of mass times the unit of velocity. So units, what is the SI unit for force?
Force.
Newtons?
Is it Newtons?
It is indeed a Newton. The SI, the International Standard Unit for time.
Seconds?
International Standard Unit for mass.
Grams?
That's the old system.
Kilograms?
Yeah, kilogram. So you could appreciate the car without the airbag then. And international unit, standard unit for velocity,
Meters per second?
meters per second. So instead of writing kilogram meters per second, you could write Newton seconds also. Or define Descartes and just go with Descartes. And if this is a typical class, some of you will use this, some of you will use this, some of you will use this.